This conference will now be recorded.
Yeah, in today's session, we're going to discuss the various functions available in the function tools. Few of the functions available or will be used in the decorators. The first one is wraps. Today, we're going to see one more function under the functional tool called LRUCache. LRUCache. Before going to the LRUCache, I want to say what is catching mechanism. Okay, what is catching? Okay, catch is nothing but if you calling the method frequently. For example, going to call that method frequently. You're going to store the results in the memory. From the memory, you can, or whenever you require, you can fetch the results. Okay, that's the purpose of catching. Catching is one approach, as well as it makes the process very faster because you are going to store your entire results in memory. The processing will be very faster, as well as you can decrease the load on the computing resources. Like you can, for example, no need to call the methods again and again. Okay, because you're going to perform the calculation, same calculation again and again. Like you can take some recursions. Recursion, what will happen? It will call the function again and again. For this kind of calculations, you can go for the catching mechanism. Catching going to store all the resources, going to store all the results in memory, as well as its execution time is going to be very faster, as well as decreasing the load on the computing resources. Unwantedly, no need to use the resources. Okay, once you can run the function and then you can store the results in the caching mechanism. And then now we're going to discuss about the LRE cache. LRE cache is a abbreviation of least recently used strategy. They are following one strategy called least recently used strategy. Now you have around 10 functions. That out of 10 functions, two functions you're going to use repeatedly going to use. The remaining 8 functions, you're not going to use it. You're not going to use it. Then automatically what will happen? This LRU strategy, it's going to remove from your memory whichever function object is not used. It's going to remove from the memory. That's the purpose of least recently used strategy. Now we're going to see the few examples about LRU. Hold a minute. Yeah, example. Batching is one of the optimization techniques, as well as you can keep your often used data, whichever data you're going to use repeatedly or going to regularly going to use the data that going to store in memory location, as well as yeah, the processing speed will be very faster, as well as you can um, unwantedly don't need to use the resources, as well as computationally very cheaper to access from the sources. Just imagine you have one newsreader application. You have an application, any application, okay, like I'm taking a newsreader application. You're going to fetch the latest news from the source. If you want to visit the same news again, what will happen? It will download the results from the server, and then it's going to pop up in the screen, right? If you want to see the same news again, you want to go to the particular URL and going to see the same results. If you keep on doing like this, you are wasting your computational power. You're wasting your computational power. In order to avoid this, they have one mechanism called catching mechanism. In that catching mechanism, whichever the news you're going to read frequently, for example, you are yes, in the news you're going to read only sports. That sports content is going to catch the memory. If later if you see the results, okay, it will get from the memory. It won't download from the server. Okay, that's the purpose of catching. Now, previously we have used on memoization concept. Under the memoization concept, we have used dictionary. In the dictionary, we will store the results. Second time, if you're calling the function, you're going to get the results from the dictionary. Okay. Now, look at here. I have one code. Okay. I have imported one module called request module. The module called request module, and then I creating on a cache. It's one of the empty dictionary. Now I have written on a method called get article from server. Get article from server. Now what I going to do? I'm going to pass a URL, any URL. You can pass the google.com, any URL. Okay, you have to pass some URL, and then from that URL, you are trying to hit the URL. You are trying to get the, you are sending a request to the URL. From the URL, going to get the response. Okay, now you are going to pass a URL in the function, and then through request API, you're going to send the request, and then the return you're going to get a response. The response you're going to get is text response. Okay. Now I have one more method, get article of URL. Article of URL. In that I want to pass URL. If whatever URL passing, if it is not in the cache, if it is not in the cache, now cache is it's a empty dictionary. Okay, if it's not the cache, then it's going to call this method and going to find the responses. From the response, you're going to extract the text, and then you're going to store the result in the form of key and value pairs. URL will be a key. Whatever text you're getting, right, that's going to be the value. Okay, first time if I'm calling the method, I have to pass this URL http rel python.com sorting algorithm python I have to pass. If you pass, what will happen? If you pass in the method, what will happen? You will check in the whether it present the cache or not. If it's not present the cache, it's going to call this method. From the server, it's going to hit your whatever request you doing, right? It's going to hit your request and then going to finally get the response. The response you're going to get the text. If you are calling the same method again, what will happen? First we'll check whether the URL is present the cache or not. Yeah, already URL is present the cache because first time you call the method, right? Now the result is stored in the memory. If you're calling next time, it's going to check in the cache. If it present the cache, what will happen? It won't go to the if condition. Directly will come to the return statement. Directly will get your directly pass a key, cache of key, you will get the corresponding value. From the cache you'll get the value. Okay, now what I'm going to do, I'm going to copy the same code. Okay, just paste it over here. Just take functions. In that we have decorators, new, keep Python file name like they don't keep decorator, keep like a memoization. It's come under the concept of memoization. Just have to import the module. If you don't have the module, first time if you don't have the module, what you have to do, you have to go to the terminal. You have to go to the terminal and then you have to install the module pip install request. Already it's installed. If it's not installed, it will install this module, and then from this request module, what I'm going to do, from this request module, I'm going to comment this thing. This is a get article method. In the get article method, I'm going to pass this URL real Python sorting algorithm Python, and then what will happen? Going to check in the cache. If it's not present in the cache, it's going to compute the results. After compute the results, it's going to store in the cache. Okay. If I run the script, you will get, first it's going to print getting article, and then you go check the if condition. If condition be satisfied, it's going to give the boolean value true because this URL, what are the URL passed, right? That will not present the cache, and then it's going to compute the results. Now it's going to call this method. After that, it's going to print fetching article from the server, and then what are the URL given, right? That will produce a response. From the response you extracting the text. Okay, now if you use the print statement, you might get the text. Yeah, these are the results. It's fetching from that URL. You can see, right? These are the results. It's fetching from the URL. You can try the different websites as well. Okay, I'm sending a request and then getting the response. You can type like google.com. See, when you are sending the request google.com, what will happen? It will send to the server, HTTP server. The HTTP server will return this HTML response. You can see, right? Response. You can right click and inspect. You can right click and inspect this window. Through the inspect window, you're getting some HTML responses. How you're getting the HTML responses? Whenever you hit the URL, it's downloaded from the HTTP server. Once it downloaded from the HTTP server, it's coming back again to the client. This is my client, right? This is my client. This is the actual responses. These responses you can able to see now. Now it's fetching from the server, right? See, it's giving the entire HTML script, document, HTML scope, style, everything it's giving, right? And then class name, everything is providing. Whatever you can see, it's providing everything. Now, my question is, if I call the same method again, whether it's going to do the computation or it has to get the results from the cache. That's my question. For our understanding, remove the print statement. This concept is nothing but memoization. Hit article, and then as of now, I comment this thing. You can see first it's printing getting article, and then fetching article from server. Okay, and then it's not printing any response because I have not used any print statement. Now, if I call same method again, just will give the URL over here, https://google.com. Now, what will be my results? Whether it will going to give fetching article from server. If I call this method, whether it's going to give fetching articles from server or not. It won't give, because first time it's going to calculate and then going to compute all the results in the cache. Okay, from cache only it's going to compute. It won't print this fetching articles from server, because if condition satisfied means then it will go inside. If condition is not satisfied, directly it's come to the return statement and then catch what are the URL passed, right? That's going to key. From the key, it's going to get the value. You can see. First time it's printed getting article and fetching from server. Next time you're calling this method, same method, it's printing only getting article. It's printing only getting article. This getting article is printed. Okay, and then if questions are satisfied, they directly come to the print statement and getting the results. Okay, this is a concept of caching. It comes under the memoization. Now, I'm going to say what are the caching strategies we have. We have a different caching strategies. For example, though it's a dictionary, if I am reading if I'm getting some huge responses, every response I can't keep in the dictionary. Okay, that dictionary will tend to expand. The dictionary tends to grow indefinitely because I can't keep this much contents, right? I can't keep this much content. For example, like I can say like 20 MB of contents I can't keep. For example, if I printing these responses, I'm getting some huge responses. I can't keep this thing in the dictionary. For that, I want to follow some different strategies. See, this kind of response I can't keep in the dictionary, so that I want to follow some different strategies because the content of dictionary is going to grow indefinitely. If the user downloads more articles, okay, or they are storing many contents in memory, definitely it's going to cause the application to crash, causing the application to crash. Okay, in order to overcome this issue, like that's this some workaround is there. The workaround is called, these are the various workarounds. One is first in first out, last in first out, LRU, least recently used, most recently used, and recently least frequently used. Least frequently used. And then now we're going to deep dive into the only the strategy called least recently used. In the least recently used strategy, what's going to happen whenever user hits a request, it's going to download from the HTTP server through internet. It's going to download from the HTTP server, and then it's going to store the results in the cache memory, which are you are using frequently. That is going to store on the top of the cache. For example, if I going to read some news article frequently, that news article results will be stored in the top of my cache. Whichever article you are not infrequently visited, that is going to store in the bottom of the cache. That is called least recent cache. Least recent cache, whichever most recent cache results will be stored in the top of the cache memory, and then whichever you are infrequently used, that is going to store in the least frequently, that's going to the bottom. Now if a user visiting two articles frequently, there we have some priority. Okay, this article 2 is you are frequently visiting, that's going to have highest priority. When compared to article 2, article 1 is having some lowest priority. Okay, in this fashion it will arrange in the cache block. Okay, whichever infrequently acts, that will be stored in the bottom of cache. Finally, the LRU strategies, what will happen, whichever article you are not frequently visited, finally it's going to remove from the cache memory. Okay, it will maintain some fashion, like whichever frequently used, it's going to store in the order. Whichever article you are not frequently used, later it's going to remove from the cache memory. This is how LRE will work. LRE is nothing but least recently used. This is how LRE works. Okay, because we don't have sufficient memory in the cache, right? We can store like 10 articles, 20 articles you can keep. If the article is not frequently used, then you can to remove from the cache memory. That's the strategy of LRU. Evicts the least recently used entry, because I'm not using frequently. Then I have to remove the from the cache memory. That's the use of LRU. And then one more advantage we have is, whichever entries means whichever information you are using frequently, that information will be reused, because everything is stored from the memory, cache memory. You can reuse the same contents again and again. And then we have so many studies are there, like most frequently used, and then least frequently, LFU, MRU, LIFO, FIFO is there. But as per the decorators, we're going to use only the least recently used. Least recently means we're going to keep the recent entries, and then we're going to remove the least recently used entries. We're going to evict the least recently used entries. That's the purpose of LRU. Okay, now I have different articles. I have different articles. Article 1, Article 2, Article 3, Article 5, and Article 8. Now, I'm keep on frequent accessing the Article 2. Now, it's going to store on the top of my cache. And then when compared to Article 2, Article 1 is less frequently used. That's why I kept below of Article 2. And then when compared to Article 1, Article 3 is less frequently used. When compared to Article 3, Article 8 is less frequently used. When compared to 8, Article 5 is less frequently used. If the cache memory is full, if the cache is full, what will happen? It finally is going to remove from the bottom whichever article is present, it's going to remove from the memory. That is called LRU. Okay, least recently used. Up to memory is full, it is going to hold all the articles. Once it's full, it will see whichever unused objects it's going to remove. Now I'm going to show the implementation of the LRUCache. For LRUCache, I want to show the performance level, right? I want to show the performance level. Without LRU, what's the performance, and with LRU, what's the performance? For that, I'm going to use Jupyter Notebook using Anaconda 3. Yeah, just create a new notebook, Python 3. Now, first I'm going to implement factorial of a number without LRUCache decorator, and then I'm going to find the time. After that, I'm going to use the LRUCache decorator, and then I'm going to compare the both the times without LRUCache and with LRUCache. Then you can see the performance, how the performance is good in with LRUCache decorator. For this, I'm going to have a simple program. I'm going to have a program called factorial number. Already we are well versed in the factorial number, right? Now, first I'm going to write one function, define. It's a uncached one, so I'm keeping some like uncached factorial, and then give some arguments like number, and then like I'm going to write some if condition. If number less than equal to 1, I'm going to return 1. Using recursion, I'm going to find the factorial number. Recursion nothing but it's going to call the function and until some specific condition is satisfied. It's going to call the function repeatedly until some specific condition is satisfied. And then I'm going to use one more return statement. Return number into uncatched factorial, and then number minus 1. Okay, I'm not using any catch decorator or LRU decorator. I'm not using any decorators. Now I'm going to find the performance for this. Okay, now you can run the script, and then I'm going to use modulo of time it. Time it. Yeah, I have time it. Time it. I'm going to call this method name uncatch of factorial. I'm going to pass a value of I can pass factorial values. Okay, 8. We'll keep 5. 5 factorial value is 120. Now you might have a question, what's the use of time 80? Okay, the time 80 is nothing but it's going to calculate the time for each loop. Because if I passing 5, what will happen? If we pass 5, first is going to check 5 less than equal to 1. 5 less than equal to 1. The Boolean condition is false. Then it's going to come to return statement 5 into uncatched factorial number 5 minus 1. 5 minus 1 is 4. Again, I'm going to call this method. Like this is going to happen repeatedly. I want to calculate the time. How much my loop time? I want to calculate loop time because it's going to 5 factorial, 4 factorial, 3 factorial, 2 factorial going to calculate, right? I want to calculate how much time my loop took. Okay, for that, if we execute the script, it will calculate how much time this looping happened, how it will give the exact time. How many seconds it took? 877 nanoseconds it took. 877 nanoseconds. And then each loop took 139 nanoseconds. 139 nanoseconds. For example, yeah, we will go for some big numbers in factorial. Okay, then we can able to see in milliseconds. The time it is going to calculate how much time the method took in looping. That's the purpose of time 80. Now you can see it took 1.7 microseconds. Mus means microseconds, but each loop took 271 nanoseconds. 1000 nanoseconds equal to 1 microsecond. Okay, 1000 nanoseconds equal to 1 microsecond. Now the total time is 1.7 microseconds. Your looping time took, and then sorry, total time is 1.7 microseconds, and then each loop took 271 nanoseconds per loop. Now I'm going to use the LRU strategy. The LRU strategy, what going to happen? It's having the both catching mechanism as well as it's going to handle all the requests and all the requests. For example, if I calling 10 methods or 15 methods, whichever method you are using frequently, going to keep the top of the stack, top of the cache memory. Whichever you are used infrequently, going to keep the bottom of your cache memory. If the cache memory is filled, whichever you have the bottom, it's going to remove from the cache memory. That's the purpose of LRUCache. Now I'm going to implement the same thing in LRUCache. Now I'm going to have one more method, define. I'm going to do the same logic. Cache method name is cache tutorial. Cache, okay, cache like you can keep like tut. Cache, sorry, cache factorial. And then cache factorial you can give, and then you're going to pass some numbers. Okay, and then what you can keep the same logic. Instead of writing a new logics, you can keep same logic here. That's it. Now I'm going to use a decorator. What decorator I'm going to use? LRUCache decorator. If you want to use LRUCache decorator, what I have to do? I want to use the module. Which module? Function tools. I want to use from functional tools. Import LRUCache. Import LRUCache. Okay. Now you can use a decorator at the rate of LRUCache decorator. Okay, and then see, I'm going to give one more argument, max size. Okay, max size is nothing but you can give the cache memory size you can give in terms of KBs. In terms of KBs, I can give like 20 KB, 25 KB you can give. Okay, but I don't know what the max size I'm going to give. None means nothing. Okay, now I'm going to find the same thing again here. I'm going to use time IT. Want to calculate the each loop time. So that I'm going to copy the same script. I'm going to change the method name. That's it. Method name is cache factorial. Now we're going to calculate time. Let's see. What's the time? See here. Total time it took 93.3 nanoseconds. See, the performance is really good if you use LRUCache. Whenever, see, in your use case, I'm saying in your company, if you are using the method frequently, okay, you know that we're going to call the method again and again. Then you can use LRUCache. It's going to store the results in cache memory, as well as if you're calling multiple methods, all are in the LRUCache, right? All are having the LRUCache decorator. Then see which function is called repeatedly. You're going to keep in the top of the cache. Otherwise, going to keep in the least of the cache memory. Once the cache memory is full, it's going to discard from the bottom only. Okay, and then each loop time you can see 13.5 nanoseconds, but here it took 271 nanoseconds per loop, but here it took 13.5 nanoseconds when compared to uncached. Cache is having some good performance. LRU cache is having good performance if you are handling the multiple functions. Don't cover a single function. If you compare with multiple function, then you can get good performance. Now, next thing we're going to see partial functions. Partial functions. Partial functions. What we can say of partial functions. Okay, partial functions. Hold a minute.
This conference will now be recorded.
See, now we're going to see another functional tools module function called another function called partial functions. Partial functions are derived functions. Okay, for example, we can keep some pre-assigned input parameters. For example, if a function takes two argument, a and b argument, I'm going to do some addition. A equal to b equal to 3. Now, my client said to me the b value is constant. B value is constant. B value is 3. It's not going to change. Then you can create some partial function with the value of 3, and then he is saying to you the a value might change. At the time, what you can do, you can create some partial function. You can have a fixed value of b equal to 3, and then it will create a partial object. From the partial object, you can call that partial object, and then you can pass the a value whenever you require. That's the meaning of partial. Partial means I don't know the exact argument what's going to come in the a value. I know only b value is going to static. B value is going to be static. In future, it's not going to change. Just get a partial function that's going to return a partial object. Through the partial object, you can call that corresponding a value. It's going to compute the results from the partial object. That's what I'm saying here is partial functions are derived function that have some pre-assigned input parameters. Pre-assigned input parameters, and then using a functional tool module partials, you can create a partial functions, or we can say it's object. First thing is replication of existing function with some argument already passed in. Already we have passed b value. I'm going to replicate same function again. That's what I'm saying is replication of existing function, some argument already passed in. And then second thing is I can say like creation of new version of existing function, new version of existing function in a well documented manner, I can say. Okay, this is the use of partial function. Now I'm going to show the implementation, how to implement the partial function. Just go to the different notebook, have like partial functions. I want to import what module I want to import. Already the module I imported is from functional tools, right? From functional tools, you have to import partial. Okay, yeah, you import partial, and then import partial. You can do. Can I go for some adder method? Can I go for some adder method, adder subtractor method? I can go. This time I'm going to use multiplication, and then I want to pass two arguments, a comma b, and then I'm going to return a into b. It's a product actually. It's a product. Okay. Now I'm going to use a partial function in Excel. For that I'm going to use product, right, equal to, I want to call this function partial of. In the partial function, you want to pass what I want to pass. I want to pass the method name I want to pass. Method name you can pass, and then I going to your client said to you b value is somewhat static. It's not going to change. It's not going to change. Now I kept b equal to 3. If I print this prod, it's going to return a partial object. It's going to return the partial object. You can see functional tools are partial. It's going to give only memory address, but it's giving the value of b equal to 3. Okay, because you are not know about the a value, what value is going to come later. Okay, that's you create a partial object. It's going to give the memory address for the particular object in terms of hex value. Now I'm going to calculate the value. How to calculate in the sense, just pass print statement. In the print statement, you can pass product of. I'm going to pass a value now. A value I'm going to keep 2. Now I pass in 2. Already I have 3, right? 2 into 3 will be, it's going to give 6. This is how you can create a partial function. If you don't know what argument is going to come in the later, or what are the arguments you have right now, you can create a partial object. From the partial object, you can call as here, you can call the reference, okay, and then you can pass a value. You can pass like this as well. A equal to, let's see, and then you can change the value because b value is constant, right? B value is going to keep on changes. 73, 21. 73 will be 21. This is how you can able to create a partial function. What I can do, okay, now I'm going to talk about the partial arguments, partial keywords and partial functions. First one is partial arguments. Partial dot arguments. The partial arguments, it's going to return the positional arguments. It's going to return the, okay, right here, we're going to return the positional arguments pre-assigned to the partial function. I can say pre-assigned to the partial function. Okay, now I'm going to show how to apply the partial arguments. It's going to return the positional arguments pre-assigned to the partial function. Okay, what are assigned, right? That's going to return. Now I can keep like print statement. I'm going to use f. F means formatting. F means formatting. If you use f in front, it's like a formatting. I'm going to do some string formatting. I can keep like function of, the first one is arguments, right? First one is arguments. What I can pass. Okay, I can keep like string name is partial arguments, comma, prod dot arguments. Okay, prod dot arguments. Why it's not giving any value? Let's see. It's not giving any value. Okay. Prod dot args. It's returning nothing. Why it's not doing anything? Why it's not giving anything? Product arguments are given. Okay, this is a partial function. What happened to this? Product dot ERGS. Why it's not giving any value? Let it be. Not giving any value. It has to give at least b equal to 3. That's what I'm expecting is. Why it's not giving? It's giving an empty tuple. It's giving a empty tuple. Where I'm making mistakes. Call partial multiplies a method and then pass to b values 3. Okay. Print of prod dot. This time I will type keywords. Okay. Yeah, it's giving keywords. Keywords means like in terms of dictionary is giving b values 3. B is a key and 3 is a value, right? It's giving keywords. And then one more print statement I can try. Keywords, arguments. I want to know the function name. I want to know the function name. Prod dot func. Yeah, it's giving the function multipliers. Okay, it's giving the memory address. Okay, fine. What about arguments? Prod dot args. Okay, leave that part. Okay, see what I'm trying to show here is if you want to know about the your partial function memory address, you can use func function. Okay, you'll get the memory address of the partial function. And then if you want to know about what arguments you have passed in the partial function, b is a key and 3 is a value, right? That's why I used prod dot keywords is going to give key and value pass. Key, b is a key and 3 is a value. And then if I pass prod dot arguments, it has to return 3. I don't know why it's returning empty tuple. Prod dot arguments. Why it's returning empty tuple? Okay, let it be. Now we'll focus on the partial methods. We'll focus on the partial methods. The next topic we're going to see is partial methods. The partial methods, I want to use one module called from functional tools. I want to import the function called partial method. The partial method is similar to partial function, but the partial method is used as a descriptor. The partial method cannot be callable. The partial method cannot be callable. Once I started implementing, then we'll know about the partial method. For that, I'm going to have one class. The class I'm going to keep its animal. Okay, and then I'm going to have one constructor. Constructor, what I have to do? I have to use the init, and then I'm going to use class instance self keyword. In that, I'm going to have one variable called species. Species, species equal to. I'm going to have a lion. This is lion, and then I'm going to have one more method come out of constructor. The method name I'm going to keep. I'm going to set the species. Set the species. Species. Okay, and then the first parameter should be a self, and the second parameter I want to pass as an argument. Argument is nothing but the species. Okay, I just copy paste species. Now I'm going to use a class instance self dot species equal to species. Self dot species equal to species. I have one method, set species method, and then I have one constructor for this class. Now I'm going to use, okay, let it be. I'm going to use the partial method. For partial method, I'm going to use one variable set underscore rabbit. Variable name is set underscore rabbit, and then I'm going to use a partial method. Inside the partial method, you see if you use double tap, what are the arguments you have to pass it to display. Okay, I will use brackets and then you have to use a double tap. Now in the partial method, what I have to pass, I can pass method name as an argument. This partial method comes in the higher order function. You can pass function as an argument to the another function. Okay, partial method is function. You're going to pass set species in the partial method function, and then what species are going to change, because this method is having some argument, right? Species argument. Now what I going to do, I going to pass an argument. The argument I going to pass in terms of key and value pairs. Species equal to rabbit equal to rabbit is equal to rabbit. Now you have to say set species not defined. Okay, set species, why is set species not defined? It's defined, right? Okay, set species. Just copy here. Why is name set species not defined? Set species not defined. Split species. Why is species not defined?
This conference will now be recorded.
Now, see here. Now you have to inside the class you have to mention this method. Okay, partial method. In the partial method, you have to pass the set species method name, and then what are the arguments you want to change? You want to change is a rabbit. Now I'm going to create an object. Like keep some object reference. I'm going to keep object underscore one equal to reference equal to animal, and then you have to call the constructor. It's going to call the constructor. Now the species will be a lion. Now it's going to species will be lion. If you want to know the value, you can use a print statement, and then you can type object underscore one dot species, because self is nothing but yeah as instance, right? Now it's going to print lion, but I want to change to rabbit. I want to change to rabbit. Now what I can do? You want to convert to rabbit, because in the constructor what are the value assigned, that's going to print as a species. Now what I can do, I going to change object one thing but yeah current class instance dot set rabbit, and then call this variable in terms of method. Okay, set rabbit. Now if I print object one dot species, object one dot species, it's going to give rabbit. Okay, don't consider this print statement because initially when I create a constructor, it's going to give species line. If you run the script, it's going to give the rabbit. See, this is the use of partial methods. Partial method means you already know this method is going to keep value is going to keep on change. Look at here, set species method value is going to keep on change. Instead of lion, sometimes tiger will come, rabbit will come, dog will come. Okay, this argument is going to keep on change. For that, what we can do, you can create a partial method. You can call the partial method using functional tools, and then whatever method you want to create a partial object, you can call the method name, and then whatever arguments you want to pass, you can pass over here. Species called rabbit, and then you can assign to a variable. Okay, assign to a variable, and then okay, you can use the class instance dot set rabbit, and then you can able to change from lion to rabbit. This is the use of partial method. Partial methods, it's a only a descriptor. It's only a descriptor. Descriptor means I given only description. It's not callable. It's not callable means you can't able to call, but through reference you can call, but directly you can call this method. Okay, that's what I'm saying. Partial method is nothing but a descriptor. I can write here. Partial method is nothing but a descriptor. You can't able to call. It's a descriptor. Descriptor. Whatever value is going to change this method, you're going to pass. You can pass species called rabbit, and then you can pass like this as well. Now we're going to use one more changes. Instead of rabbit, I'm going to do dog. Do some variable name, and then I'm going to change the species is equal to dog. If I call this method, it's going to give only rabbit. Going to give only rabbit. What I do? I want to call object underscore one dot set dog. I have to call set of dog. If you call the species, you will get the dog. This is the use of partial method. It's a descriptor. It's not a callable. You can assign the method name as well as you can pass a parameter. What are the parameters you have to pass? You can pass, and then you can create a partial object for this method, and then you can call the reference as a function like this, and then you able to you can change the value of the species. Now species is going to be a dog. I'm going to sign off this session.